And we'll go to the third one, which is checking for redundancy. So, and now this is quite a data intensive thing, but the point is that one test you can do across all of the stocks is to see just how many unadjusted close values are common to each pair of files. And this is a way for checking. It's another way too that will show up any duplicated data if somehow the same symbol has the same data. So now we'll load that file that we just created. And just check how many unique symbols it has now. So we have 1,000, we have 930, there are 1,000 stocks, 930 currently listed and 70 delisted. So one thing that we want to do here is create this data of the individual highs and lows. Now, this has already been done, and the data is there, so we'll load those in. So basically, we've split the data up into a data frame for each of the price values: open, high, low, close, unadjusted close, and volume. Just looking at the close, the head of it to see what the data looks like. So now we have a row for each date and a column for each stock, and the price in this case is just the close. So we want to look for identical unadjusted close values for the across the stock. So this means that basically we'll do each pair, so there's 49,500 of those. And so we take the unadjusted close and for each of these stocks, we're going to compare these. Now, here's the code that does this. And the comment here is that this takes several hours to run. I think it's about 4 hours to run this. But what's actually going on in here is, so you're for I in range and J in range. So basically, it's just looping through all pairs of the symbols, and it looks at the indexes of the places where the values are the same. And then on this line, by shifting the indexes back one and subtracting one from them, so for instance, if it's identical in index 2, and so the two values of the stocks are equal at index 2 and they're equal at index 3, then this moves them back, and it says that there's a run of, when the two indexes after this process of shifting back and subtracting one are equal, it means that you have two consecutive values. So it's just finding the runs of values. And then if there's more than 20 identical values, then we add that pair to the ones that we need to look at. So let's have a look at. So this
so let me highlight that if you are, sorry, Roger. So if there's one thing you want to take away from this notebook, that's the algorithm, for checking duplicates. That's the core of the.
Right. Basically, that's what we're really showing here. Is this is certainly a way to check for equal values, and of course you have to do it on the unadjusted closes again. So these are the ones that finds after about 4 hours, and so we're going to have a look and describe what the algorithm provided. So notice that So what this does is it has these cases. So if they're both, all the values are identical, then equal values and they have the same data. If one is contained within the other, either way. So the final case is the incomparable case where there's a mixture of values. So you can see here, for instance, ramp and AXEM prime, they have 485 equal values, and everything in ramp, ramp itself contains everything in ACXM prime. So that's kind of interesting, right? But it suggests that, for instance, this stock was delisted or it changed its name to ramp. ARAV and VSAR, the same thing, and it's kind of suspicious that one is an anagram of the other, right? So here's an example. These two here have 44 equal values in 5 different runs, but neither contains the other. Well, what's going on there? So these are the cases, neither contains the other, right? The interesting cases. And if you look at a few of those, let's see here. Here, there's obviously something different here. Well, Goog and Google, right? That gives us a clue about that. And so we have a double up there. Here's one that there are 3 runs and they have a very large number of them. We'll see that the shorter runs like this, where the common values and they're not contained, are typically, there are good reasons for why that's happened, but it's going to be accidental. So these are the symbols that this tells us that we're going to remove because one is contained in the other or they are identical. And these incomparable pairs are the ones we want to look at. So let's get rid of the ones here, and we're saving that